All right. Okay. So we're live here with Jason McCampbell, who is from Wallaroo AI. And one of the reasons we wanted to chat today was that of players that are in the MLOps space, you're one of the few that is a huge Rust shop, and you're using those capabilities to really leverage inference, uh, you know, optimizations via the language, and that's kind of the genesis of this. And do you want to say a little bit more about your background and introduce people to some of the things you're doing?
Absolutely. Nice to be with you, Noah. Uh, as you said, I come from Wallaroo AI, and we're definitely a Rust shop. And one of the big things that it's bringing to us is that we're looking at is how do we speed up inference? How do we reduce the amount of overhead in there to get data in, to get data out? How do we reduce the cost to do inference? And Rust has some really nice properties there in terms of compiling to very efficient code, but then also memory management reduces a lot of overhead, reduces bugs, the concurrency primitives. So I think that there's a lot to dig in there.
Yeah, and in particular, one of the things that's interesting is as I've gotten more into Rust and drank the Kool-Aid, so to speak, is that you start to look at services that are very popular services, and then you go, oh wow, that's in Rust. So like the one that I think many people don't know is that AWS Lambda is written in Rust, right? They open sourced Lambda, and you also see a lot of emerging new technologies. I was just talking to somebody today about the a what is it, a vector database company that is written in Rust, and then these search engines are written in Rust, and so for me personally, the some of the hobbyist type programming I'm doing, I've really been interested in the fact that Rust has such a great story in terms of compiling, where if your
Hmm.
code compiles, and it's it's annoying sometimes, like to get everything to compile, but if once it compiles, you know that you're protected from a lot of security bugs, you're protected from many race conditions, and also you get this extremely low memory and extremely efficient code. And one of my big critiques, I guess, about the current state of machine learning is that in some sense we're a victim of our own success, in that there's all this amazing things people did with Python, and there's all these awesome data science libraries in Python, but when you really get into the problem of operations, right, it's a very different, like the word operations implies efficiency, and so
Hmm.
it's a very different process to you know do some charting, or do a script of some kind, versus I want to do inference 500 million times this year, right? Or I want to combine multiple computer vision steps, because I think the buzzword for it is composite AI, right? Where you're using multiple
Hmm.
models at the same time, and merging those all together. Then you start to get into, it's not even really a what you would consider data science at all, in many ways, right? Because you're basically worrying about the efficiency of something, like how quick does it run, what's the least amount of memory you can use, how do I lower the cost, and so that's where I think that's in looking at languages like Go, Rust in particular, which are the newer generation of languages that can compete with C++ and C, that it does seem like if you're going to do MLOps, you should at least consider A, companies that use Rust for inference, and then B, maybe you should also consider it yourself. And it looks like some of the libraries are actually starting to get there, in terms of there's PyTorch is pretty works pretty well
Hmm.
in Rust. I've had some experience with that, even with GPU. I've had experience with Hugging Face in Rust. I've had experience with the Onyx, which just got merged into Microsoft's branch just like yesterday, I think. So that's kind of maybe sets the stage a little bit for I don't know, maybe a question I would have is how is your company using Rust to deliver awesome inference?
Yeah, so I completely agree, and we were all cheering once Microsoft adopted the Onyx runtimes for Rust. Um, the I think the code was from Nicholas. I forget how to pronounce his last name. Um, great open source contribution, um, one man show, and now Microsoft has formally brought that in. TensorFlow has official Rust bindings, um, and you know, you're exactly what you're saying. I can't agree more. What we'd often see is you take these really highly tuned engines like the TensorFlow core, the Onyx core, and you run models in it. But then what you see is that people have to roll their own solution. So they end up taking Python and throwing a Flask framework in it and writing a little server. And now you have hundreds of milliseconds of Python code running on top of what may be a 10 millisecond inference time. And Python's a great language. It's useful for very many things. Um, Performance is not one of the strong suits. Python is single core, at least C Python specifically is single core inherently. Um, it's hard to push it for speeds. And Rust was sort of that aha moment. I've done C++ for 30 years, high performance computing. It's always C++ with Python or Tcl on top. And Rust was the first one where you kind of get the best of both worlds. You get the safety and the higher order programming of a higher level language without all of the foot guns that C++ gives you.
Yeah, and it's interesting that's been my experience. I have less experience with C. I mean, I've written some commercial projects where I got paid. I've written my own commercial software in Objective C. But I wasn't necessarily really happy with that. I was like, like, but Rust feels so different in that it feels like you said a merge between Python and like a C like language. And one of the analogies that I've been throwing around a little bit is that, well, there's two analogies that come up. One of them is this idea that that you should think of a language as a sports team, like the Eagles versus the Chiefs or whatever. And I think that's not a good strategy because each one is a different tool, and they're going to have different capabilities that are unique to it. And as you mentioned, I don't think anybody is going to say Python is a high performance language. It's amazing at prototyping, and I can
Mhm.
write something in Python just by thinking. I mean, I can literally type Python so fast that in some sense my brain is is ahead of where my hands can even keep up. But that's a very different tool than something where you really are trying to get high performance. That's one aspect of it. And then the other
Mhm.
aspect of it is the this idea of the evolution. And the Tickle author just recently mentioned something in an interview I read, how there's new languages that come every 5 or 10 years or so, and I think he mentioned even Rust in there. And I think I think it's a pretty good paradigm for people to think about, which is that if you look at any revolutionary change, I mean, CPUs have gone through so many different iterations and single core, multi-core, clock speed periods, that those have gone through. You look at cars. I mean, we had my friend in high school had a 1969 Ford Mustang with V8, and 3 speed, and it would peel out through all 3 speeds, and you're like, wow, this is amazing. And then you realize, like, wow, it's burning like it gets like 5 miles to the gallon,
Yes.
and like there's just you didn't care about energy efficiency in 1969. And then you look at the evolutions of cars and how they've gone through different changes, and now the car is basically like an iPhone. You just plug it in and it charges, and so like, how could you possibly think that decades ago the same paradigms and same things would be the same today with automobiles or chips or whatever. And then if you look at a language, like, well, when was a language invented? I mean, like, if you look at C, and was C, like, was it 1979 or 80?
Six, oh, I
Or
think it was 67,
really?
69, something
Ooh,
like that.
wow. Yeah.
Kernigan and C, I mean, they wanted a portable assembly language. Um,
Yeah. So, I mean, if you look at languages, or Python was 91, I think, or something like that. And like, how could you possibly, no matter how brilliant you are, be able to think multiple decades into the future about what's, what features you're going to need? So I think a kind of a different way of thinking about software languages as well is, what's the age of the language and the adoption, right? So it's
mhm.
just because the language is the most popular, or the second most popular, the third most popular, it doesn't necessarily mean that it should be the solution for everything. And it's just like, if just because the VW bug sold millions and millions of VW bugs, that doesn't necessarily translate to, people that are, wanting to use electric vehicles. Or, I mean, you could in theory gut the engine on the VW bug and do some electric things to it, and but it's like, why would you do that? So I think that to me is one of the paradigms of Rust. Is so those, just to kind of cap it up, is the, not being a sports team type person, being able to be thoughtful about which solution you're choosing. And then the second is that people may need to consider the age of the solution that you're using.
Yes, yes. Yeah, nobody says I'm on Team Hammer or I'm on Team Screwdriver and I only use one or the other. You pick the one that's appropriate. But I really like your thoughts on the age of the language because so much has changed since some of these languages have evolved. You know, it didn't used to be that you had to worry about malicious inputs to speak of. Things weren't on the internet. Now you have all the internet background traffic that if anything's exposed, all those different input patterns are going to be changing, and you'd better have a hardened input, a hardened process. Um, you also have changes in compiler technology and just the amount of compute power that we have available. You know, in the 70s, if you tried to run the Rust compiler, you'd spend hours and hours waiting for the compilation to finish, and it wouldn't be worth it. Whereas nowadays we have so much compute power, and in fact, the Rust compiler is actually threaded, which I haven't seen a mainstream language with that before. It was always, each process, each file is a single threaded process to do the optimization. Rust is multi-processed, so you can do so much more in terms of understanding the program and being able to optimize it and look for defects, look for, concurrency errors and stuff like that. It's, languages have to change with the times, right?
Yeah, so you could even say, I think a couple ways to look at it would be that you should at least consider the age of a language and its unique properties when you're looking at a problem. Like,
Mm-hmm.
and I think MLOps in particular, my opinion is that the age of the language and the features of the language should be a heavy component of why you're doing something, because of the efficiency needs, like especially as you get into things like, LLMs, and needing, if you're going to download a the Whisper transcriber, the large model, I think it's 5 gigs or something like that. I mean that's a big file. So
Yes,
you you
yes.
you want to really have, and that's actually, maybe we can even segue into this a little bit, is that's exactly the kind of problem where there's so many commercial content companies that could benefit from transcribing historical data, right? I mean, there's just, I mean, I can't even imagine all the use cases. But then if you get into using something that is burning tons and tons and tons of energy and costing you tons and tons of compute, you may just say, look, we would love to transcribe all of our text so that we can then summarize it and then automatically create metadata about our audio collection or our video collection. But we just, the computational requirements are just too much based on Python, for example. On the flip side, maybe if they're using your solution for inference, or they're using something with Rust or both, that basically it could be possible because the efficiency is really suited to the job that you're doing. So I think that's another way of putting the problem as well, is instead of just saying that I'm on team this or I'm on team that, it's that instead of that, for a second, saying that there are many problems that people are probably very interested in solving, that if the language performance that the language performance itself is actually preventing you from solving.
Yes, yes. Although, so it is interesting. Cost per inference is certainly a big component, like you said, of if it's going to cost me $5 to do all of this translation, it may not be worth it. But even more than that, a lot of times what we find is just the human cost. If it takes you 3 people to develop a model, to deploy it, to maintain it, but then models are only as good as their data and people's behavior changes, so now you have to keep track of it and you have to monitor it and understand how it's performing. That's the other big piece of it that I'm very involved in and is really interesting to me, is how do you make it so that the same number of people can deploy 10x the number of models? Because once you do that, then you get that cost down further, and you open up just this whole suite of applications where, it may be that before a model would have to save the company $1 million a year or generate an extra $1 million a year to be profitable. If you get that cost down, oh, well, this will save us $250,000. Well, sure, that's still great to do. Go do it. You open up more and more avenues that we can go explore.
Yeah, we're getting a little bit of audio breakup, but I don't know if there's anything you can do on your end. But yeah, it's a very good point. Is like not only just the inference, but I think one of the things you mentioned was that the idea of even being able to do multiple things at the same time, so that you're able to create a pipeline of work that is able to do everything in one step, versus maybe you have this diaspora of like this thing and that thing, and they're all kind of thrown everywhere, and you're just burning up so much compute because things are running in many different layers. Or I think one of the topics that is kind of an interesting one to bring up is that, yeah, if you're hosting your own inference based solution, for example, using like some off the shelf Python framework, what are some of the things that you could potentially lose by doing that?
Yes. You have the compute overhead. You have to now set up your own observability back channel and how do you get the data back. But then you're also using your engineering talent to go and develop something that is there really a value add, or is that something that you can go off the shelf? Lots of companies used to think, hey, we'll build our own cloud data centers, and you go, wait a minute, no, we don't need to do that. We'll just go buy that because you do it once, and now it's a commodity. You just go ahead and buy it.
Yeah, and I think maybe I could even, if I go to your website real quick, one of the things I could do is just describe here Wallaroo. Is that when I'm looking at your products, that you basically are talking about lowering the cost of the deployment, 12 and a half times faster inference, launching things faster. It is, so you're basically focused really on the operate side, right? Like if I'm looking at your website, and I'll even throw a link in there for people if they want to take a look at it. But basically, actually what I can do is, wait, we have the technology here. Let me just do this. Let me just share this inside, and then we can just talk about it. So basically, the what is kind of interesting about this is that you can see that there's other solutions that people are using. They're using things like Databricks, which does have a nice interface for running queries and notebooks, and then maybe when you're developing, you could be doing things with PyTorch or SageMaker, etc. The part that your company is specializing in, that's highlighted here, is basically the last part of it, which in many ways is the most expensive part of a real world machine learning problem, right? Is actually the deploying, the running, observing, and then optimizing the model.
Yes, absolutely. And that was what we found is that if you're a large software company, one of the big tech companies, if you're a Wall Street bank, you can afford to hire a boatload of PhDs and go develop custom models, and then hire a whole army of software engineers to write the infrastructure to deploy these models and do everything full custom. But that doesn't scale. And we've seen these ecosystems develop over time where there's first data warehouses that developed. We have lots of good data warehouses out there. Then we started developing more training tools. There's lots of tools for training, but there was really a gap when it comes to the production deployment. And production deployment meaning you have load balancers in terms of that. Is it replicated? Is it highly efficient to run all the time? And can you get that observability data back so that the data scientists can look at it and understand how it's working? And when they retrain a model, can they just push the model out? Can they just update it? Or does it require a bunch of work? You have to float over the wall and have somebody go through and deploy it for you. So how do we both make the data scientists more efficient in being able to get these models up? And how do we offload some of this work for machine engineers and the ops folks so that they can focus on the higher value added systems and not just heavily using the day-to-day work?
Yeah, so I'm getting from your company, I'm getting a note that says, "Can Jason reconnect his audio or switch to another source?" Yeah, I think if you want to try to switch to a different audio source, and in fact, we could even see if you can toggle to like I don't know if you have either another mic or if you have. I can't hear you now, but how about now?
Oh, yeah. Can you hear me?
Yeah, way better.
Oh, good. Okay.
Yeah.
That's my earpiece. I would have expected it to be worse quality, but that's great.
Perfect. Okay. Yeah. It's
Awesome.
even better. Yeah. So we're, so basically, looking here, what's interesting is that, if you look at a lot of machine learning platforms, that it seems like in some ways, a lot of them or MLOps platforms, a lot of it's focused on, I would say, more the load prep develop side of things.
Mm-hmm.
And what's interesting about this is that in some scenarios, if you are going to start from zero, you may not want to start with some of the technologies that exist today. Like, for example, I think some of the Spark based workflows are obviously necessary. People have a lot of pre-existing code, but if you were going to start from the very beginning, it may not be the most efficient solution, right? Like you could potentially figure out a different solution. And so that's what's kind of interesting about what your platform is focused on, is you're focused on the part that is in many ways less of a legacy based adaptation, right? Where if you have to build tools for loading and prepping and developing, then in some sense you have the legacy issues. Like, well, like let's just take TensorFlow. Like, well, there was TensorFlow 1, right? And then now there's new TensorFlow, or if you're looking at Hadoop, and then there's Spark, and like there's all these like legacy things that are there for a good reason, and companies need to use them. But in terms of machine learning, inference in particular, things have really started to it feels like accelerate in terms of, it seems like we're in many ways like at the early stages of a very big revolution that's going to happen where if the things that you mentioned in your product, like if the deploy, the run, the observe, the optimize, if all of those are actually solved, there could be many companies that are going to do machine learning that maybe they felt like they couldn't because of they're so, you know, in the weeds with the loading and the prepping and the developing that they're just overwhelmed. But when you think about the problem, maybe instead of thinking it at those first stages, you think of it at the last stage and say, well, wait, what if I actually for a second here want to really think about the operations of things? And that's kind of my area of interest as well. Like I've definitely spent time, you know, working for companies in these other areas. I've, you know, taught classes in these other areas, written books in these other areas. I personally am less interested. I mean, I'm not like completely uninterested in training models and deep learning. I think there's some interesting things there, but I'm personally just much more interested in the operations side of things because that's actually what's happening in terms of a solution. Like, you know, you're making your company money or you're solving a real problem, especially when you get into things like the large language model revolution, where there's just so many really awesome solutions that are off the shelf that you could use that would maybe add value. Like we were just talking about, like transcribing your
Mhm.
text or summarizing your text. And then now it does really matter. It really matters the efficiency of what it is you're doing. So I don't know if you wanted to expand on that a little bit and kind of dive into some of the things that your product does, you know, the edge-based aspects of it, how, you know, you can build once and deploy many, and anything at all in terms of that particular spot.
Oh, absolutely. Well, and it's interesting because you mentioned the democratization. So that's one aspect of it is, we're seeing a huge variety of companies that are looking to leverage AI and ML, but they're not traditional tech companies. Sports teams, real estate, actually multiple uses in real estate, retail, when you're talking about dynamic pricing and how do we adjust the models, demand forecasting, or even just simple things like analytics on how many people are in queue for a checkout line or something like that. Or traffic analysis is very similar. So lots of cases where we've taken tools. You can go and set up a data warehouse. You can use some of these training tools, but then the question is, well, what do I do with it? I train the model. Data scientists aren't software engineers typically by training. They're, in terms of deployment. You can take your training tool and they often offer some deployment options, but that's usually not what the tool was designed for. So some of this is just the maturation of the ecosystem as more companies are diving in that direction. And then you mentioned edge, which is actually one of the areas I've really been focusing on because it's coming up everywhere. And what it turns out is edge, what I originally thought of edge is some little device that you attach to your door for a doorbell, or you have sitting around your house somewhere or in a factory. But when we start talking to clients and customers that we're working with, that could certainly be edge. It could be a piece of factory equipment, high-end factory equipment where you're running models to tune the behavior of it. But edge can also be, say, a server rack in the back of a big box store where you're monitoring a bunch of cameras for security or analytics or something like that, traffic analysis. So again, now edge is also a small data center or a server rack somewhere. Well, but then also customers and people want to deploy models to be to the cloud to be close to their customers. So they want to deploy to China, to Africa, to Europe, to all over the place. And now that ends up looking like edge as well. So suddenly there's this whole explosion of edge is like, well, that can be anything from a remote data center down to a little Raspberry Pi type device.
And that's, I guess that's, if we talk a little bit about your solution, could you walk me through, like, if you were running, let's say, PyTorch, for example, and you wanted to then use your product, what would that give somebody the capability of doing? Let's say it's I don't know, like computer vision, model that, I don't know, does classification of a bunch of different things. What would be the step then that would be involved with your product, and then what capabilities would it give them?
Yes, so great question. So most of these models, PyTorch definitely included, can be expressed as a graph of functions. So that's what Onyx and TensorFlow under the covers do, is they express these computations as a graph of operations to be performed. So what we'll do is we'll bring it in, and most of the time we can convert these models to, say, an Onyx model. The big advantage to that is the Onyx core runtime is a very small runtime engine, highly optimized. It can run on x86, it can run on ARM, it can take advantage of GPUs. It's a very flexible framework. So what we really want to enable is, instead of somebody taking that model and wrapping it into a container with a bunch of Python code, or you have to hand it off and convert it, have somebody manually convert it into some other model and bake it into a container image, the data scientist just says, export this. And now you have this exported pipeline. It could be multiple Onyx models chained together. So a very common one would be, one model does object recognition. So it's identifying specific objects in an image, and it outputs the bounding boxes. And then a follow-up model does the classification, where it's going through and figuring out what's in each of these bounding boxes, and outputs a big vector of data saying, oh, I think this one's a car, this one's a cat, and so on. So we can take that whole pipeline, chain it together, and deploy it into our engine. Now that engine, one of the neat things about performance, and what Rust gives us, is if you're looking for low latency, for very fast turnaround time, say that you have, it could be anything from you're detecting credit card fraud, or doing something based on user clicks and you need a fast response, or even running on a 5G cell tower, which is something I've dug into a lot more than I ever expected. But there's a 10 millisecond timing loop in a lot of them. So you need to have inference in about a millisecond. But that same efficiency for performance also translates to lower cost of operations in terms of dollars per inference, or it means you can lower your footprint and run on smaller hardware. So the idea being that now you can take this model pipeline that you've built, and you just say, well, I want to go deploy it to a bunch of x86 servers in the cloud. Well, I want to deploy it to ARM servers because they give me a better cost efficiency. I want to go deploy it to this edge device, and here's the engine, here's the model, go ahead and just run it. And in all those cases, it should be really easy to deploy, but you should also still get all of the feedback, all that observability data back, so that the data scientist can still monitor it, because, I mean, people's behavior, the world's behavior changes, and you need to be able to update the model, and it doesn't matter whether you're deployed to the cloud or to the edge, or anywhere else for that matter.
Got it. So it sounds like the problem that you're solving is that you're able to take somebody's machine learning project and optimize it so that it runs as efficiently as possible, saving people on costs. And I'm assuming you're doing this because that's Rust, right? I mean, that's essentially one of the core capabilities that you're tapping into. Rust and Onyx are part of your solution. But you're operationalizing it in a way that allows people to do it without needing to necessarily get into the weeds. They could come from any language, as long as it is has something that has a pathway to Onyx. Is that correct?
Yes, and we can certainly run other models too. I mean, worst case, we can generate a container image and run that as well. But most of these libraries can be expressed as a graph, so they can be converted to Onyx or TensorFlow or either of them. And so we speed it up, but it's less that we speed it up by doing anything fancy. We speed it up by just doing some of the basic plumbing legwork of being very efficient. You reduce the number of data copies, hopefully 0 data copies. you get the thread locking right, use the Rust concurrency primitive so we can use multi-core processors very efficiently, and then don't throw a whole stack of other stuff on top, so that we try to get whatever the raw performance of these underlying runtimes like Onyx and TensorFlow, that we can give, as close to that core performance as possible.
Yeah, that's pretty interesting. And you're also, I'm assuming, then deploying, majority of the time you're deploying a binary, then not a container.
We'll typically deploy our engine as a container,
Okay.
but instead of being a container that's running one specific model, it's running our engine, and you can hot swap in different pipelines as you want. So, and yeah, so you can swap in different pipelines. You can change out what's being run, but it can run an entire chain. You can do in-process orchestration, so you can run multiple steps all in the same process, and you don't have to have multiple network calls. You don't have to have multiple containers all spinning and consuming resources.
Yeah, the part that I think does drive me a little bit crazy about machine learning operations right now is that there's so many solutions, as you mentioned. You're working on something that's performance is basically almost the entire problem is like low latency and cost and everything, and then you throw like this 4 gig container or 20 gig container onto a virtual machine, and you're like, yeah, we're good, and then you put Python in front of it or something. It's like, ooh, that's not really the problem we're trying to solve. That's definitely like a kind of like a high school project, where it's you're proving you can put a machine learning system together. But what you mentioned, I think, is probably what most companies are interested in solving is, look, we just need it to run extremely fast, and we don't want to spend a lot of money.
Yes, and particularly at scale. But I would say even the step before that is, you have the data scientists, they build this pipeline, it's working. Okay, I just want to go run it. I wanted to run it on here. I want to go deploy it somewhere. We don't want a big software engineering rework process where somebody goes, oh, well, all the libraries that you use, those Python versions, now I need to figure out what exactly those are and go try to build a container that matches that. And well, I'm going to rewrite some of the code so that it fits with our container deployment strategy. And what we see is a lot of times you end up with this whole rework process, and it can take days, sometimes weeks even, to take a model that's done and actually get it out into deployment. That should just be push button, here it is, go download it, and it's ready to run. Oh, you want to update it? Great. You tell the engine, update to the new version of this pipeline, and it's done. That quick.
Yeah, and I guess another use case we haven't talked about is there's some companies that maybe don't want a data scientist, right? Maybe they actually just want to take, they know that these models exist, and they may even be okay with even using them stock, so to speak. Like, hey, for what we do, fine tuning models is really kind of a nice to have, but not a must have. But we're, maybe a real estate company or, some other company that's in that a non, core technology space, just wants to use some pre-trained models for things. And they're, I don't know, maybe it's to detect the features of a house so that they can put it up on the sale, right? Like if you have a picture and we just want to see like how many rooms are in the house and estimate whether they have a pool or, whatever, something like where it doesn't have to be perfect, but it maybe saves people time. Is that something you also are targeting?
It's interesting. It's not a core target, because usually you have to have some data science to understand what value you can get out of your data. But I think with the sophistication of the pre-trained models that we're seeing, I suspect that is going to change, where now suddenly the pre-trained models are so good that you really can just say, I'm going to take it off the shelf and I'm going to deploy it. And now it's running, and now you have to have a service, and you have to have all of the stuff that goes with it so that it's always running and always available to whatever services are connecting to it. So I think, yeah, I think that's the direction that we're probably headed.
And what about the part that I think is interesting about Rust in Onyx is that we had a long period in our history where people were writing Linux command line tools in C, right? Like, and they're amazing. There's like, I was just using MD, was it MD sum today? Or I was checksumming a file just with the built-in MD. I think it's MD5 sum. I think I forget what the name of the checksum utility is. It's like, oh, somebody wrote this really cool utility 30 years ago, or I don't know when they wrote it, 20 years ago. But none of these C-based tools were necessarily designed for security, A, and then B, they're not definitely not using machine learning. But now that we have Rust and Onyx, we actually, and they're obviously putting Rust into the Linux kernel and all kinds of other, really awesome open source projects, is that people could actually start to build Linux command line tools, or even just, binaries that you just distribute as a command line tool that actually have an Onyx model built into it. Is that a use case that would fit with what you're doing too, or would that be kind of supplementary?
I think that would be supplementary. That certainly I use a lot of Rust-based command line tools, and I love the fact that people are starting to write the classic Linux command line tools, Unix command line tools now in Rust and take advantage of multi-core access. Rip, grep, dust replacing du, fd replacing find, and these are multi-threaded versions of the same tools that run many, many, many times faster. It would be very interesting to start baking in some ML into some of those tools to do better prompts. Certainly some of them have already some very, very basic types of intelligence. You mistype a option, it says, do you mean this over here? That isn't some place that we would go in terms of our engine would be a fair amount heavier than what you'd want in just a single command line tool. But it is a general industry trend. I could certainly see somebody linking that in and coming up with a clever use of ML, even on command line tools, right?
I'm assuming that because I haven't used your product, but I'm assuming that you can export out of it as well as it would.
Yeah. So usually what we would do is a data scientist builds a pipeline, and you hit deploy, and what we'll stand up is a load balancer in front of one or more Kubernetes pods that's our engine running an HTTP server. And then you can come in with JSON. You can come in with Apache Arrow binary format if you're doing high, large data types of things. So we would stand it up as a service that you could connect to.
Yeah, I miss more because I'm a command line tool type person myself, and I always like to think about this style of development, which I don't know if it's in vogue as much as I use it, but where you build like a lib.rs file, or you build your logic, and then you build a command line tool first to prototype it, and you just kind of like you get it working, and then you're like, yep, that's what I want. And then you just say, make it a web app, right? Or make it an inference that might be, an interesting thing in the future. I'm just brainstorming, less saying that that's a hard requirement for anybody, but that what's kind of cool about that kind of scenario is that there may be some companies that are interested in having like, companion type command line tools. Like maybe they have their core, like I'm just thinking of maybe a product like Grammarly or something like that, where there you may want to embed so you may want to build once, deploy many. It does seem like you have a story there though, right? Maybe not the command line tool part of it, but you have a story where you build once, deploy many.
Oh, absolutely. And going forward, that's going to be something that teams are going to want to see more and more of is, I built this pipeline, I want to deploy this one to x86. This other pipeline well, I want to go deploy this one to ARM. Oh, this is my CV pipeline. Okay, I need to use a GPU for this. So I want to use, it could be ARM or x86, but I need to have it backed up by a GPU. I'm deploying to something really small here. So, I mean, it could be a Raspberry Pi, even a little ARM processor. So you want to scale everything down and have just sort of the minimum bundle and put it out there. In all of those cases, it's still typically deploying as a service because you want to be doing many inferences. But I mean, realistically, the difference between a little HTTP service and using a Unix socket or having a C API, that's a relatively small amount of packaging. So you could bundle it in. For a CLI, you'd probably want to keep the service running because it's relatively heavyweight, and you want your CLI utility to start up in milliseconds. But then it could connect using any sort of IPC method to this running service that performs the inferences. Maybe it's recognizing, recognizing vague descriptions in a bunch of text. So when you're grepping your source code, you don't have to get the wording exactly right. It just does approximate matching and says, yeah, this is what you were looking for.
Yeah, just thinking like, especially because iOS is another interesting area where, I've been playing around with CreateML. Have you ever played around with CreateML before?
No, I haven't.
So in Xcode included this almost like Easter egg tool that I started to tinker with. That's kind of interesting in that, in some sense, it's like a proof of concept for the Core ML format, and that basically you could take any popular computer vision data set. In fact, it does a lot of different types of machine learning problems, tabular data. But let's just take computer vision. You can take the dogs and cat data set and just drop it onto CreateML, and it is shockingly it comes up with models using AutoML that are much higher accuracy than even ones that kind of a novice would build. And then it gives you the core ML file, and then at that point, I guess the reason they built this tool is so that it would be easier for developers to do AutoML and then add a model into iOS. But it seems like with your product as well, that could be, because the core ML Onyx story is pretty good, right? Like there's like a pretty good bidirectional pathway that someone could do that process, right? They build some kind of computer vision model, they deploy it out into production, and then, like when I was a CTO, we had to deploy to Android, we had to deploy to iOS, we had to deploy to the web, and you so in that case, I guess you were saying that the simple way would be would just be to talk to the service, but there may be a reason for some people potentially because maybe it's a the iOS device can't talk to the network a lot, that maybe there is a need for like a less network version of it.
Yes. Well, that's something we see a lot is, sure, you'd like to deploy to the web, to a cloud service because clouds are great. You can scale up as far as you want. They're really cost efficient and so on. But if you're talking about, 10 different cameras monitoring an area, you really don't want to be streaming 10 video streams all the way up to the web just to do the processing. So yeah, you probably want to have a box running locally, probably with a GPU, that you can just do all that local processing, and then when you find something interesting, you go and stream that video up somewhere. But computer vision, and I think audio probably will follow, are big classes of applications where you want to push it out to the web, or out to the edge rather, just like you were saying, where you don't want to stream it off of your device necessarily and go up. And certainly a lot of the phones run ML models doing exactly that sort of thing. Or even our little voice assistants, you say, hey, whatever, and that key phrase is identified on the voice assistant locally, because you don't want to have audio streaming to, the big tech companies 24/7. They don't want that. Just when you hear that key phrase, it detects it there, and then it says, oh, I'll send this text snippet up.
Yeah, I think that is a really interesting area. Is that you as we see people getting higher performance tools like the one that your company is building, that I think there is going to be a lot more of an expectation that you're using machine learning in your products.
Mhm.
And it may, the expectation may not necessarily be that you're building everything yourself, especially if the technologies are like, like in the case of Whisper, the transcoding or transcribing technology is so good that are you really going to make it better? I mean, maybe, but why wouldn't you just use the thing that they have, and then you're I guess in some sense the users are now going to start expecting machine learning and everything, and so yeah, that further goes into the point of you can't be having like a research laboratory in your company where you're barely just getting everything to work every time. There has to be a rigor to it.
Yes, yes. And even more than every product expected to use it, every business will. If you're selling tickets to a venue, uh, it's going to be more and more expected that, hey, are you doing dynamic forecasting? Do you have a model that gives you an idea of what ticket sales will look like, or that help you price the tickets so that you can, both maximize revenue, you're not leaving money on the table, but also how much money to spend in terms of advertising? Is this going to be a blowout, or do you need to be getting some information out there, and what sort of advertising maybe is most targeted and reaches the people would really be interested in the event?
So in terms of people using your products, what would you say are the 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 pathways? Like, so let's say a student wanted to sign up and build demos in your project. Is that a cohort? And then also, if you're, I don't know, currently using SageMaker or you're using Databricks or something like that, and you're like, like the solutions they have are not exactly what I'm looking for. I wanted to build something that like you said, like more centered around Onyx, high performance. Like what does somebody do? Is there like a trial period for your product, or like how does
Mhm.
that actually work?
Oh, absolutely. We have a free community edition. So anybody who wants to try it out is more than welcome to download it. You can spin it up in a small Kubernetes cluster. You can run it on a single VM, and it gives a full experience of how to use it. So you can just take a model, deploy it, bring up the pipeline. Um, that would be a great way to prototype things if you just want to see, I have a bunch of data that I need to run through. Okay, deploy this pipeline, pass all the data through it, shut the pipeline down when you're not using it. And then what we will of course do free POVs, proofs of value, with prospects and companies who are interested and think they want to move in this direction. And the most common case for a company along those lines would be sort of what you described. They're using SageMaker, or they're using Vertex AI or Azure ML or Databricks or something. They've trained the models. Maybe they have a couple in production. But now what you have to do is take the next step, and it's how do we grow and scale our production? How do we deploy it more easily? How do we bring back that observability piece so you can do drift detection and you can really analyze the performance of it long term over time? So, somebody who hasn't deployed any models, it might be a little bit premature, although it still makes sense to get the production plan in place before you have too many in production and too much legacy to deal with. Um, but that would be the sort of thing where, oh my gosh, all right, we have models, now we have to do it. I can't afford to hire a bunch more staff to have 5 times more models. I really need to figure out how do we focus on the highest value add, building the models custom to that business, that organization, and then get those things into production as quick as possible.
So with all of those platforms like Vertex AI, SageMaker, you know, all of these have model registries. Is that really one of the syncs that goes into your product? Does it go right from the model registry, or is that something that
Mhm.
you do as well?
Uh, So we do have model registry services, but typically, yes, you would take the model out of the registry, and we have various levels of integration, and we're always adding more. But you'd pluck the trained model out of the registry. You say, "Yep, this is good," and you can just straight from the Python environment in, say, Databricks or something like that. You can run our SDK, stick it into Wallaroo, and deploy a pipeline in a matter of minutes. And now you have an endpoint that you can start testing, and you can do load testing. You can verify the results are as expected, and then it's ready to go.
Yeah, and I think that's that's a pretty strong use case in my opinion, because and I mean, and I'm not trying to say Databricks is a bad product, but Databricks, the queries are great. I mean, it is,
Mm-hmm.
I love, going in there and, working with big data and doing all kinds of cool stuff in the notebook. But I wouldn't necessarily call the next step fun, which is like, okay, let's launch these really slow VMs, like waiting. It's like when they're crunching and they're getting up, and it's like, let's
Yes.
take this like really clumsy, like Python package system, and let's like make this explosion of files that like have weird things in them, and then let's put that into that VM. Like that isn't that I mean, for a prototype, sure, but and I mean that I'm that's one of my critiques of I don't. I mean, obviously, Python, when you're doing queries in a notebook of some kind, there's some value there. I mean, obviously, people are
Mm-hmm.
using it, and but then when you get into Python for serving, that's when I think it really starts to fall apart. Is that
Yes.
I just don't think that's the use case for Python, and that's why I have my my kind of critique a little bit about ML flow is that the
Mm-hmm.
model format and all that. It's like, ooh, there's too much stuff there. I don't want all that. I just want there's a model, and I just want to put it into production, and I want it to be fast.
Yes. But it's been, I mean, in the past, it's been hard because you go, well, I need to serve this model. What do you do? Well, you don't want to go out and learn all of Java and spin up a whole Java environment to try to serve it. Um, Nobody wants to write an HTTP server in C or C++. That's painful. That's a lot of work. So, I mean, to some degree, it's just been, well, what else am I going to do? This is quick and easy. I'm already using Python for the analysis, so I guess I'll write a Python server and get my model running. And then we all know what happens to prototypes is somebody goes, great, it's working. Yeah, but it's a prototype. Fine, it's close enough, ship it. and suddenly your prototype's in production, right?
And costing your company a lot of money,
Yes, yes.
right? Because and I don't know why cloud vendors have all done this, but the I guess it's been less. Google hasn't done this as much, but other cloud vendors have done this. Is that this idea that like virtual machines are the natural place that we should start at for a model is like, I kind of disagree there, just because it could cost you just hundreds of dollars a day, and it could be just doing nothing. Like
Yes.
it's just sitting there, and it is barely doing anything. So I do think that the area that you're playing in is a really big wide open field where I just haven't seen many solutions where companies are focused on what you're describing.
Yeah. I mean, production deployment, even prototyping deployment, it should be fast, but you have to have auto scaling. You want to have load balancing. You want to have all of these features because you're exactly right. You end up throwing away a huge amount of money if you're just spinning a server the entire time, a whole VM. Well, then you can go in, and Kubernetes is great for orchestrating containers if you really want to dig down to that level. But that's really tedious. That's several steps removed from actually serving a model. So, just like we don't go and most people don't actually manage individual servers anymore, you have a fleet of VMs, and Kubernetes does most of it. It's the same thing. Don't go manage your models directly. Just let's have some automation on top of that, and you tell it what you want deployed, and let all these different stacks of software scale up, scale down, and manage them for us.
Yeah, it's definitely sounds interesting. I learned some stuff that I'll definitely take away. One of them is that you have a community edition, which I'll definitely play around with, and and I think that's a good idea too. The community edition, just so that people, I think sometimes that when there's a product where it just says contact sales, that can be a black hole, right? Because
Yes.
like, well, I would contact sales if I knew what it did, right? Like, that's kind of the chick. But I'll
Yes.
definitely play around with that. It definitely sounds like the spot you're in is a very interesting spot.
Yeah. Well, I'd love it if you play around, and then if you have feedback and ideas, we're we're all ears. We love to hear feedback and you know different thoughts and use cases that you may be playing with.
Yeah, and if I'm assuming that, there'll be probably some people that are looking to contact you and
Mhm.
hear more about your product or whatever. I'm assuming they can just go to your website, right? That's the easiest way to find all this stuff out.
Oh, absolutely. Our website. You're welcome to hit me up on LinkedIn. We have a community as well, so a Slack channel and stuff like that. So if you're not looking to be sold to, you're not looking to buy anything right now, you just want to get it to know the tool better and everything. We're very, very happy just to engage, provide some information, um, you know, and talk ML and ops and everything. We're all nerds in that regard.
Cool. Yeah. I mean, I from from our conversation, I'm certainly intrigued, and the stuff that you're doing. I mean, just the fact that you're using Rust for the inference to me tells a lot about the way you're thinking as well. So yeah, I'm glad that I had a chance to talk to you, and I'll definitely try your product out, and hopefully some other people can play around with it, and looking forward to talking to you in the future.
Yeah, likewise. I've enjoyed the conversation. I'm glad we got a chance to talk today.
Sounds great. All right. Well, I'll let you go, and thanks again for all your time.
Thank you, Noah. Take
Okay.
care.
Talk to you later. Bye.